Okay, so today is optimization part 2 and 3. So we're still dealing with maximizing and minimizing a certain function. So in the first couple examples, we're going to be optimizing revenue functions. So we're going to create a revenue function based off the information given in the problem, and then we're going to optimize it so that means take the derivative, set it equal to 0, solve for x, and then take that x value and plug it in where we need to. Okay. And so for example 1, when a management training company prices its seminar on management techniques at $400 per person, 1,000 people will attend the seminar. The company estimates that for each $5 reduction in price, an additional 20 people will attend the seminar. How much should we charge for the seminar? And how much should we charge for the seminar in order to maximize its revenue? And what is the maximum revenue? So again, it's all given in the problem. We need to maximize revenue. Maximize revenue. Okay, which means we need to create a revenue equation. So in step A, we're going to set up an equation for price and set up an equation for the numbers of customers. Okay. So I'll leave the problem up there. And let's start with price. Of course, you don't want to write today. There we go. Price. And for the price equation, we're charging $400 per person. So we're going to have $400. But then in order to get more people to attend, we're going to do a $5 reduction in price. So we know it's 400 per person, but every time we do a $5 reduction in price, 20 people, an additional 20 people will come. So this equation is going to be 400 minus 5x, because it's for each additional $5 reduction. So the more $5 off we give, the more groups of 20 will come. So there's our price equation. And now we need a number of customers equation. Number of customers, sure. Okay, well, at $400 per person, 1,000 people will attend. So we know that 1,000 people are coming already. But then for every $5 reduction, an additional 20 people will attend. So this means that if you do one $5 reduction, 20 people will come. If you do $10, 40 people will come, so on and so on. So the formula for customers is going to be 1,000 plus 20x. And here is the amount of customers that will come based on the price of this seminar. All right, that does look ugly. Let's do this. Maximize revenue. There we go. Okay, which means we have enough information to set up our revenue functions. And remember, revenue is given by the amount of items, or the number of items, the number of people, the number of customers, times the price. So to set up our revenue equation, it's going to be R of X equals the number of customers. So all of this is the number of customers. This will represent that X variable. We're going to substitute all of that in for X. So you're going to have 1,000 plus 20X times the price, which goes in for P. 400 minus 5x. Okay, and there's our setup for the revenue function. We just have to FOIL everything out to get it and then simplify. But any questions so far? All right, then let's FOIL. Where's my calculator? 1,000 times 400. That is probably 400,000. Yep. So we get 400,000 minus 1,000 times -5, -5,000x, plus 20 times 400, you get 8,000x minus 20x times -5x, -100x squared. Okay. Now clean it up. Put the highest variable first. -100x squared. You can combine those terms. -5,000 plus 8,000 gives me positive 3,000x plus 400,000. Here's the revenue function. Okay. And after you create the revenue function, take the derivative, set it equal to 0, solve for x. We are optimizing it. So this means that r prime is going to be negative 200x plus 3,000. Negative 200x plus 3,000. Okay. And then all we have to do, set it equal to 0 and solve for x. So r prime of x equals 0, negative 200x plus 3,000 equals 0. I'll move that 3,000 over. You'll get negative 200x equals negative 3,000, and then divide by negative 200. And watch that. Gone, gone. 30 over 2 is 15. X equals 15. Okay, well, 15 is the maximum number of price reductions we can give to get more people in. So this is the number of price reductions. Okay. And now all we have to do is take that 15, plug it into the revenue function, and then plug it into the price equation we made, and we should be done. Okay. So 15 into revenue. Let's do that first. I have the revenue function up there. So you're going to get R of 15, and I'll get negative 100 times 15 squared plus 3,000 times 15 plus 400,000. Let's see what our max revenue is. And if we do a max number of 15 price reductions, we'll get 422,500 bucks in revenue. That'll be max revenue. Okay. And now, in order to get this revenue, we need to see what price we should sell these tickets at. So price was 400 minus 5x. So 400 minus 5 times 15, that's 400 minus 75. And we're going to sell these tickets for $325. Okay. And then if it says what's the maximum amount of guests that come, Who knows? Well, we'll just plug 15 into the number of customers. 1,000 plus 20x. And we'll get 1,300 customers. Okay. And again, that's optimization on revenue function. Only difference in this one, in these types of problems, we have to create the revenue function from the given information in the problem. But hey, that's not bad. The seminar, you make 422,000. That's like those seminars people go to with the what is it? Oh, like Rich Dad, Poor Dad or something, right?
Yeah, the ones that are like, I'll tell you the secret to get rich, and the secret is that you make a course about how to get rich.
Exactly. Like, look, you're making people pay $325 to $400 per ticket. They're like, pay me this much, and I'll tell you how to get rich. All right. So, any questions on this problem? It's all about the setup, right? Okay. Why is there an X on that? Oh, I don't know. Okay. Or is that a no? Okay. So, second one, exact same setup. So, 2, a car rental agency rents 200 cars per day at a rate of $30 per day. For each $1 increase in rate, 5 fewer cars are rented. At what rate should the cars be rented to produce the maximum income? And what is the maximum income? So here we are maximizing income, which for these types of problems, we're going to treat everything as a revenue problem. So you're going to get income, you'll get gross income or gross revenue, but treat them all as revenue functions, just like the last problem. Okay, which means let's go ahead and set up some equations. So we'll call this step A. So we need to know how many cars we are renting, the number of cars we're renting, and the price. So I guess we could start with price. Here we rent 200 cars per day at a rate of $30 per day. So price, and then I'll even do number of cars. So 200 cars at $30 per day. And then we increase the rental rate by $1. So that means it's going to be 30 plus 1x, which means the x represents each $1 increase. And if we do this, 5 fewer cars are rented. So it would be 200 minus 5x. So for each $1 increase, 5 fewer cars are rented. Okay. So we need to figure out how many increase rates we can do before people stop renting our cars. Okay, which means we have the price, we have the number of items being sold, which means we can set up our revenue function. R of x equals x times p. Remember, the amount will all go in for x. So we get 200 minus 5x, and then price, of course, goes in for p, 30 plus x. There's our setup. Now let's go ahead and FOIL. 200 times 30 gives me 6,000. And then 200 times x is 200x minus 5 times 30, 150x minus 5x squared. Okay, clean up, highest power first, negative 5x squared. Combine your x's, I get 50x plus 6,000. Okay, there's our income or revenue. I guess I could change it to I of X if I needed to. I'll just put that here. We'll just say that this is income. Okay. So R of X, and there's our income or revenue function. Okay. And now we need to optimize this. We need to maximize it. So of course, we're going to take the derivative. So R prime of X, find the derivative, and we should get negative 10X plus 50. Set the derivative equal to 0. And negative 10X plus 50 equal to 0. Move that 50 over. And then divide by negative 10. We should get X equals 5. So 5 is the total number of rate increases that we should do before people look for another rental place. Although, find me a rental place that has cars for $35 per day. Or is that normal? I haven't been out in a year.
Same.
Okay. D. Now all we have to do is take 5, plug it into our income / revenue function, and then plug it into our rate and number of cars per day. So we're going to say D, find max income, price, and number of cars. Why not? So first off, get rid of the long one, R of 5, plug this into our revenue function, negative 5 times 5 squared, plus 50 times 5, plus 6,000. And if we do 5 rate increases, we'll make $6,125 in max income. Okay. And now price. I think it was just 30 plus X. Yep. So 30 plus 5, which means we'll rent our cars out for $35 per day. And then if we do 5 rate increases, this means the number of cars that will be rented, 200 minus 5X. So 200 minus 25 is going to be 175 cars. Okay. Not bad. So again, use the information, set up your revenue function or income function, which is the same exact thing. Set it up, simplify it, take the derivative, set it equal to 0, solve for X, take that X value, plug it into revenue, price, and number of cars. All right. Any questions on that one?
So what this is saying that, so you take the revenue function, and for each increase, it eventually hits a point where, I'm sorry, you go down to 175 cars instead of 200.
Exactly, because remember that we are increasing the rate. So if you're increasing the rate that your cars are being rented at, people are going to start to look for another rental company because they don't want to pay $35. They want to pay the $30. So this is why if we can do $5 in increase, this means that we can still get away with renting out 175 cars.
Oh, okay.
Yeah. I guess think of it more of like a money perspective. Like we're trying to get away with as much money as we can by increasing the rate. But of course, if you increase it too much, people are not going to want to rent your car.
Right.
All right. Because if you left the price rate at 30 and they took 200 cars, like if you didn't increase the rate at all, well, 200 times 30 is 6,000. So you would lose out on that $125 extra of income. So if we just push the limit by $5, we'll make $125 more.
Yeah, that makes sense, because then that's 25 less cars that are going to be in rotation being used.
Yeah. So I mean, yeah, of course, there's probably a lot more going on in the background.
Yeah,
Here, we're
that's
just pinching out the numbers.
yeah. Sorry. Yeah, I'm doing. I think I'm on my second semester of economics and accounting, so I'm like, that's all the background going on for me too while
Yeah.
we're doing this.
You're like, what are they doing? Why are they doing this? And I'm like, hey, just think about the numbers, and there's no, because we're not getting a cost associated with it. We're not getting a profit. We don't even know who came up with these numbers. We're just computing them.
Got it.
Yeah, but it's good to ask questions like that, especially if you're doing accounting, economics, and all that. I mean, those are in the back of my head. I'm like, well, what's going on? Like, what's the cost? Like, we got to fuel them, da da da. That's all comes into play, but we're not worried about that.
Yeah, all that stuff is why you don't find them for $35 a day.
Exactly. All right. Okay. Example 3 is just like the last two. We can skip it or do it. What do you think?
Can I just get the setup part?
Sure. So maybe you could walk me through setup, right? Let's see if you can do it. So you got a 300 room hotel in Las Vegas. It's filled to capacity every night at $80 a room. For each $1 increase in rent, 3 fewer rooms are rented. If each rented room costs $10 to service per day, how much should management charge for each room to maximize gross profit? What is maximum gross profit? And again, these problems you treat as revenue. Even if it says profit, well, this says maximum gross profit, we're still going to set it up as a revenue function. So we're doing that. So just see it as revenue. Okay, so of course we have to set up our price and number of rooms. So what price are we renting these rooms at?
That's $80 and
80
300 rooms.
and 300 rooms. And then we are going to do a $1 increase in rent. So price or rent. So that means it's just plus what?
Plus X.
Plus X. But then with that, if we increase it by $1, then how many fewer rooms are rented?
Minus 3?
Minus 3.
Oh, minus 3X rooms. Okay.
Yeah, exactly. Okay. But then the little curveball thrown in here is that it costs $10 to service per day. So are we going to dish out the $10 or are we going to make the guest pay the $10?
The guest?
Of course. So that means we're just going to tack on that $10. And now our price equation is actually 90 plus X.
Got it.
Yeah, when I first started teaching this class 7 years ago, I was like, why isn't it minus 10? Like, doesn't the hotel pay their employees? But I'm like, wait, we're a hotel. We're going to charge the guest for cleaning fee.
Yep. Always goes to the consumer.
Yep. But then this question is definitely wrong because the only hotel I know in Vegas that does $80 a room is probably the Hooters Hotel. All right. Haven't been there in a while either. Thanks, COVID. All right.
Lights at the end of the tunnel.
Yep. All right. Gross profit. So we'll just call this P of X, but we know it's R of X. Gross profit. And it's going to be, again, set up by X times P, which is numbers of rooms, 300 minus 3X, and the price of 90 plus X. Whatever, we're almost done with this problem, so we can keep going. All right. 300 times 90 is 27,000. And then plus 300x minus 270x minus 3x squared. Combine like terms, negative 3x squared plus 30x plus 27,000. Here is our gross profit equation.
And that's where we take the derivative.
Exactly.
Negative 6x plus 30.
Plus 30. Set it equal to 0. Move the 30 over. And if you divide by negative 6, we'll get x equals 5. So again, number of room rate increases. And then you'll take that number, plug it into the gross profit equation, plug it into the number of rooms, plug it into the price, all that good stuff. So let's see. D. Let's see, we'll have P of 5, and that'll be negative 3 times 5 squared plus 30 times 5 plus 27,000. Negative 3 times 5 squared plus 30 times 5 plus 27,000. And we'll make 27,075 bucks as our max gross profit. And then price or rate of rooms was 90 plus X. So 90 plus 5 is $95 per day for their room. And then number of rooms, $300 minus 3 times 5. 300 minus 15, so 285 rooms will be rented out for if we increase the rental rate by $5. That's still not bad.
Yeah, yeah, the setup is makes the rest easy.
Cool. All right, good on that.
I'm good.
All right. All right. All right. So that finishes those type of problems. Next is part 3, which is inventory control. So again, all about the setup here. So in inventory control, X is the number of items, Y is the number of production runs. X over 2 is the average number of storage each day. Now, this comes from if you have a warehouse, one day your warehouse is full, the next day your warehouse is empty. The next day your warehouse is full, the next day your warehouse is half empty. So throughout the year, your storage, average number of storage is always X over 2. Somebody came up with this, not me. So I looked into it, and that was the easiest way I could understand it. Full, not full, full, not full. So X over 2 is your average number of storage. Okay. Now, when finding inventory control, we have a storage cost. The formula for storage cost is the cost to store an item times X over 2, the average number of storage each day. Setup cost is the cost to set up times Y, the number of your production runs. And then our cost function for these inventory control problems is going to be the storage cost plus the setup cost. And the last type of equation we have is going to be an annual demand of items, which is going to be X times Y. So in the problem, all of this information will be given. We just have to set up the equations using the information above. So that means for number 1, a multimedia company anticipates that there will be a demand for 20,000 copies of a certain Blu-ray during the next year. It costs the companies 50 cents to store a Blu-ray for 1 year. Each time it must make additional Blu-rays, it costs $200 to set up the equipment. How many Blu-rays should the company make during each production run to minimize its total storage and setup cost? So out of all of that, our job is to minimize storage and setup cost. Okay, so step A, find the equations for storage cost and setup costs. So I have those equations right there above. So let's look at storage costs first. Storage is given by the cost to store an item times X over 2. Well, in this problem, it says it costs 50 cents to store a Blu-ray. So that means we're going to have 0.5 times X over 2. And 50 cents reduced by half, we're going to get 0.25x. There's my storage. That's the equation for my storage cost. Okay, next is setup cost. Setup cost is the cost to set up times Y. Well, in this problem, it says that every time we make more Blu-rays, it costs $200 to set up the equipment. So this is going to be 200 times Y, which is just 200Y. Okay, there's storage cost equation. There is setup cost equation. And now we put it all together in the next step where it says find the cost function. The cost function is given as storage cost plus setup cost. Everything we found in step A. So for cost, it's going to be storage cost plus setup cost. There's our cost function. Okay, and now our job is to minimize storage and setup cost. So what we want to do whenever we minimize, whenever we optimize, is we're going to take the derivative of this cost function. But we can't take the derivative yet because of that pesky y again. If I take the derivative now, I'm going to get a y prime, and we have no idea what y prime belongs to. Y prime would be an extra variable that we don't need. So we have to make a substitution like we've been doing. So we've been doing substitutions ever since we started optimization. So we have to get rid of that y. And the only way to do that is by manipulating the demand equation. So first we have to create the demand equation. Demand is given by X times Y. And in this problem, the very first sentence says there will be a demand for 20,000 copies, which means I have my demand equation of X times Y equal to 20,000. Now just go ahead and solve this equation for Y, meaning if we divide by X, we divide by X, we're going to get Y equals 20,000 over X. There's my sub. And we're going to plug that in for that value of Y. Okay. Which means we're doing that all in step C. So I'm going to have to write small. I could write to the outside. Okay. So this means that you're going to get C of X is equal to 0.25x plus 200 times my new Y value of 20,000 over X. All right, now let's clean up. We're going to get 0.25x plus 200 times 20,000 is a big number. 4 million. So you're going to get 4 million. And what I'm going to do already is take that X and flip it to the numerator, making it 4,000 X to the negative 1. And now this cost function is all in terms of X. Come on, there we go. I guess I could have read that bigger because now we're done with this step. Hello, come on. Let's go. Okay. Uh-oh, I broke it. Oh, man. I'm just trying to make that bigger, but we could probably move on. There we
Is that Microsoft Whiteboard or is that their
go.
special?
It's
app?
OneNote, but this is not the program, it's the laptop. Feels like it's about to crap out because it's been doing this remote thing for over a year now. So the laptop starts to overheat. And yeah, and this one won't connect to my regular Wi-Fi. It only connects to my guest Wi-Fi. So that's why it's kind of slow too. So once this laptop craps out, I'm just going to give up and tell everybody to watch my YouTube videos.
I'm waiting for the sign off. Smash that like button if you
Yeah.
finished your homework.
Okay. So now we're going to take this cost function, all in terms of X, and minimize it, which means we're going to take the derivative, set it equal to 0, solve for X. So here we're going to get C prime of X equals 0.25 and then minus 4 million X to the negative 2. Now set this equal to 0. And solve for X. Here we go. Add that 4 million over, and I'll have 0.25 equals 4 million. And what I'm going to do again is take that X to the negative 2 and flip it back to the denominator. So now we're solving for X So this needs to get multiplied to the left side. So you're going to get 0.25 x squared equal to 4 million, and then divide by 0.25, which I believe that's just 1/4, and that becomes 16 million. So x squared is equal to 16 million. And then we'll square root both sides. And we'll get x equals the square root of 16 million. What's that?
4,000.
4,000? Good. Yes, 4,000. So we get plus or minus 4,000, but remember, we're talking about products here. We're talking about items. So we only keep the positive amount. So this means that we get 4,000 Blu-rays. Okay, and now what we need to do is take 4,000, plug it in to find Y, and then plug it in to find our cost. And that should be it. So we'll say for Y, there we go. So Y is going to equal 20,000 over 4,000, which is just 5. That is the number of production runs we need to do each year to make 20,000 Blu-rays. So for each production run, we're making 4,000 Blu-rays. Okay. And then plug it into the cost function, which is up there. And we'll have C of 4,000 equal to 0.25 times 4,000 plus 4 million times 4,000 to the negative 1. All right, calculator go. Make sure I have 4 million in there, right? And the minimum cost of producing 4,000 Blu-rays and 5 production runs is going to be $2,000. All right. Storage and setup. Okay, and that's done. So that's inventory control. Any questions on that one?
That's the minimum cost for all the production runs, or that's the minimum you can make for.
Or maybe it's the minimum per production run. Because it only says 4,000. So we're making 4,000 each production run. So per production run, it's $2,000.
Got it.
$200 times 5. Yep. All right, cool. All right, one more. Same thing. A tool company has a uniform annual demand for 9,000 premium chainsaws. If it costs $5 to store a chainsaw for a year and $25,000 to set up the plant for manufacture of the premium model, how many chainsaws can be manufactured in each production run in order to minimize the total storage and setup costs? All right. So again, let's create those storage and setup costs. So we'll call this A. Storage is given by the amount. Wait, what was it again? It was storage cost is the cost to store times X over 2. So this says that it costs $5 to store a chainsaw times X over 2. So 5 over 2 or 2.5x. There's the storage cost. And then setup cost is the cost to set up times Y. So this says that it costs $25,000 to set up. So you'll have 25,000 times Y. I mean, 2,500 Y. And now we can move on to our cost function. Cost function is going to be C of X equals storage cost plus setup cost. So there's the cost function. And now we want to take the derivative of that, but we can't yet until we set up the annual demand function. So C, demand. Demand is X times Y, and people are demanding 9,000 chainsaws. Who uses that many chainsaws? Okay. So we must rearrange this, solve it for Y. So all we have to do is divide by X. And we'll get Y equals 9,000 over X. There's my sub, which goes in for that Y. And call that D. Plug Y into C of X. So C of X is going to be 2.5x plus 2,500 times 9,000 over X. Simplify, and you get 2.5x plus 2,500 times 9,000 to 22,500,000 x to the negative 1. There's our new cost function, all in terms of X. And now we optimize. Which means take the derivative. 2.5 minus 22,500,000 x to the negative 2. Set it equal to 0. and solve for x. Right. But before I continue, are we good up to this point?
Yeah, it's good.
Okay. Okay, cool. So we'll get 2.5 equals 22,500,000 over x squared. Multiply that to the left. 2.5x squared equals 22,500,000. And then divide that by 2.5. And x squared is going to be, is that 9 million? Yes. And then square root 9 million. And we're going to get x equals plus or minus 3,000. So we only take the positive. So that means that we are going to create 3,000 chainsaws every production run. Okay. And now take 3,000 and plug it into y and plug it into the cost function c of x. So plug it in there and there. I'll leave those up. And then f plug x into y and c of x. So y is 9,000 over x. 9,000 over 3,000. So three production runs per year. And then c of x, or c of 3,000, 2.5 times 3,000 plus 500,000 times 3,000 to the negative 1. And that should give me, I think, 15,000. Whew. All right. There we go. And that finishes optimization. Any questions on that example?